Imagine you had a universe which was a Googolplex meters across, okay? So a big universe. Then that's very big, and if you actually travelled far enough in that universe, you would start to see repetitions. You would start to see exact copies of yourself.
Today we've got a Google.
A Google?
A Google.
As in the website?
Kind of, not spelt the same. It's spelt Googol. 10 to the power of 100. So imagine that that's a 1 with 100 zeros after it.
And it came about because it was a guy called Kastner, who was a mathematician. He was also very famous in cosmology.
Now, it wasn't him that came up with the name. He just thought of a really big number. He thought, what's a big number? 1 with 100 zeros.
And he wanted to sort of explain infinity, and he wanted to come up with a very big number that wasn't really big at all compared to infinity.
And he actually asked his nephew, his 9-year-old nephew, what's a good name to call this number?
His nephew came up with the word Google. But it's quite a big number. I don't think it's that big a number, but it's quite a big number. I mean, to put it into perspective, you might ask yourself, well, okay, how many grains of sand could you fit inside this room? Okay, you think that's a lot, right? That's going to be a lot of grains of sand. It's only about 50 billion. Not that much. So you might ask, well, let's ask something more dramatic. Well, how many particles are there in the universe? Okay, now that's 10 to the 80. 10 with a 1 with 80 zeros after it. That's how many particles there are in the universe. So a Google is bigger than that. And you could ask yourself, okay, well, how many grains of sand could I fit in the universe? Say the universe was full of just grains of sand. How many grains of sand can I fit in the universe? And that would be about 10 to the 90, so a 1 with 90 zeros after it. It's quite a big number, but it's not that big. There's certainly stuff that's a lot bigger than that.
You're saying it's not that big a number, and yet all these things that we think of as big, like the size of the universe and atoms in the universe and particles, aren't even touching it. So it must be big.
Well, yeah, okay, but I can think of something that is bigger than it. That's physical, that you can think of physically. So if you take the smallest volume in the universe, something like, which is a Planck volume, so it's basically a little cube its radius is a Planck length, which is 10 to the minus 35 meters, okay? And you see how many of them you can fit in the observable universe, and you get about 10 to the 183. So that's a 1 with 183 zeros after it. So that is bigger than a Google, okay? So Googles aren't that impressive, so, because we can think of things that are bigger.
He then thought, well, what's a bigger number than a Google? And for that, he took 10 and raised it to this power, the power of a Google, 10 to the 100. So this is taking 10 and timesing it by 10 and 10 and 10 and 10 and 10 and timesing it Google amount of times. And this number is called a Googolplex.
We start writing down a Googolplex, okay? And let's suppose, well, we're writing on a piece of paper here, but let's suppose we actually try to write it down on particles. So for each particle, we're going to write down a 0. So first particle, we write down a 0. Second particle, we write down a 0. And we carry on doing that on every particle in the universe, and we still would not be able to write down a Googolplex. It's too big a number. And there's something else remarkable about a Googolplex. So I find this astonishing. Imagine you had a universe. This sort of emphasizes how big a Googolplex is. Imagine you had a universe which was a Googolplex meters across. Okay, so a big universe. And in some models of internal inflation, things like that, you do get universes which could be as big as this. So we have a universe which is a Googolplex meters across. Then that's very big. And if you actually traveled far enough in that universe, you would start to see repetitions. You would start to see exact copies of yourself. Now you might think, what the hell am I talking about here, Brady? But you know, let's take you, Brady. Let's ask how many quantum states can describe the volume that you occupy. Okay, right? The number of quantum states that can occupy that volume, the total number, is, and you can work this out. It's something to do with entropy and black holes and stuff like that. But you can work it out, and it is 10 to the 10 to the 70. That's a number of different quantum states, different ways that you could actually put together that volume of space. So let's say, so that number is less than a Googolplex. Why?
So the space I'm in could be me, it could be you, it could be
Yeah.
a dog, it could be a vacuum,
Yes.
it could be anything.
Could be all those particles arranged in any number of different ways. Particles might not even be there. But all those possible states, given that volume that you occupy, the number that you could, the number of possible states you could have is 10 to the 10 to the 70. Big number. Not as big as a Googolplex, but 10 to the Google is equal to 10 to the 10 to the 100. Okay, so this number is clearly less than this number. Okay, so you occupy roughly about a meter cubed of space. There's that many different possible states that you could be in. Okay, so if you go this many meters away from yourself, you would start to expect to see repetitions. So that means that if you're in a universe which is so big, as big as a Googolplex meters across, then eventually you would start to see repetitions of those volumes of 1 meter cubed.
So just by chance, I will run into another arrangement of atoms that matches me.
Exactly. Matches you exactly. And then, you go even bigger and you would start to see entire observable universes repeated. So this is truly remarkable. I think the fact that you would go there and see your doppelganger, if you went far enough away in a Googolplexian universe, I think is just sort of emphasises how big that number really is. But the size of the universe is 10 to the 26 meters, sort of all cubed. That's the size of the universe. So this number is, tiny compared to that.
So there's probably not another me in this universe.
Probably not. But if we live in a universe which is a Googolplex across, then there probably is.